Okay, guys, let's take a look at how to write and solve systems from a word problem. Now, we already know how to solve systems algebraically by using the substitution or elimination method. So when we write these, we are either going to write our equations in slope-intercept form. If we have a constant rate of change, we will use slope-intercept form. If we do not have a given constant rate of change, we will write our systems in standard form. And then we will decide if we're going to use elimination or substitution to solve the system. So let's take a look at example number 1. It says Hailey bought 2 new candles. Candle 1 measures 16 centimeters and burns at a rate of 1/4 centimeters per hour. So we have a 16 centimeter candle and it burns, which it means it's getting shorter, 1/4 centimeter per hour. So far we do have a constant rate of change, which is the 1/4 per hour. Candle 2 is a little bit taller and stands at 22 centimeters, but burns at a faster rate of 1/2 centimeter per hour. So we want to write a system so we can answer the 2 questions. The questions are, at what hour will the candles be the same height? So how many hours of burning will they both be the same height? And what height will they be at this hour? So we do have constant rates of change. So we are going to write these in slope-intercept form. So candle 1, y, which is going to be the total height, is going to start out at the initial height of 16. So our initial value is 16, and then it burns. That means it goes down 1/4 of a centimeter per hour. So X is our hours of burning, and Y is going to be the total height of the candle. Candle 2 starts at 22 centimeters and it burns at a quicker rate of 1/2 centimeters per hour. And Y again is total height. So we want to know at what hour, when will X be the same? So what we have to do, we want to know what hour will they be the same height. So we're going to use substitution. So I'm going to take what Y equals and plug it in for the Y here. So I have negative 1/4 X plus 16 is equal to negative 1/2 X plus 22. So I have variables on both sides. And the smaller one is going to be negative 1/2. So I am going to add 1/2 X to both sides. And then this gives me, so when we add these together, we are going to get a fourth, and it's going to be positive 1/4. And now we need to subtract 16 from both sides. And now we need to multiply by the reciprocal, which is going to be 4. And X, which is ours, is 32. So when the candles are burning for 32 hours, the candles will be the same height. Now, we are asked to find out how tall the candles will be. So we can plug the X value into either equation. I'll simply just plug it in to our first one. 1/4 of 32 is 8, because 4 divides into 32 8 times 1, but it's negative. And the total height is going to be 8 centimeters. So at hour 32, both candles will be 8 centimeters. Okay, let's look at our second example. Josh needs to take his truck to the shop. Mechanic 1 charges a flat rate of $75 for a diagnostic check and $30 per hour to service the truck. So $30 per hour is our rate of change. Mechanic 2 charges a little bit more for the diagnostic test, but a little bit less per hour, so $20 an hour to fix the truck. So we're going to set up a system so we can answer the question, at what hour will each mechanic charge the same amount, and what will that charge be? So mechanic 1 has an upfront cost of $75, and then they also charge $30 per hour, and Y is going to be the total cost. So Y is the total cost, and X is hours that the mechanic works on the car. Mechanic 2 charges a $100 upfront fee for the diagnostic test and $20 per hour. And we want to know at what hour will each mechanic charge the same. So we are going to use substitution. So I'm going to take what Y equals and plug it in, substitute it in for this Y. We get 30x plus 75 is equal to 20x plus 100. So keep in mind, x is hours. We have variables on both sides, so we are going to subtract out the smaller one. We have 10x plus 75 is equal to 100. Subtract out the 75. We have 10x is equal to 25, and divide by 10, and x, which is hours, is 2.5. So at 2.5 hours, both mechanics charge the same amount. Now, let's just plug it in to see what that amount will be. I can plug it right in here. So we're going to multiply 2.5 times 20, and that is 50, plus 100. So the total amount is $150. So at 2.5 hours, they each charge $150. Okay, let's take a look at our third example. Jude's piggy bank consists of quarters and nickels. There are 43 coins, and the value of those coins is $5.55. How many of each coin does he have in his bank? Now, this problem does not have a constant rate of change, so we are going to set up two equations using standard form. So let's talk about this. We have quarters and nickels. So I'm going to use a Q and an N, and if I have so many quarters plus so many nickels, the total of the coins is 43. So this equation represents how many coins. Now we need to represent how much value does he have. So everything is going to be about the value. So the value of a quarter is 0.25. So 25 cents times how many quarters plus the value of a nickel, 0.05 times how many ever nickels, gives me a total value of $5.55. So one equation represents how many, the other equation represents how much. This is all money. So before we get started, I don't prefer to work with decimals. So we can multiply this equation by powers of 10 to move the decimal over so that we have nice whole numbers. So I'm going to multiply through by 100. That way we can move the decimal point 2 places. Oops, we forgot the N in that example. Plus 5 N equals 555. So this is a lot user-friendly than the original. So I multiplied through by 100 when I'm working with money, and that moves your decimal over 2 places. So now I have this equation, and I'm going to use elimination. So I simply either need to make this Q become negative 25, so they will eliminate, or make this N be negative 5. And I prefer to use these smaller values to keep my numbers small. So I'm going to distribute the negative 5. And then I multiply 43 times 5, and I get negative 215. Then when we add these equations together, we get 20Q equals, and then this is going to give me 340 divided by the 20, and I'm going to be able to see how many quarters that we have. So we have 17 quarters. So I can plug 17 back into this first equation and simply subtract out 17 from my 43, and I have 26 nickels. Our next problem, the 8th grade students from Creek Middle School and River Middle School are going on a field trip. Creek Middle School takes 4 buses and 6 vans with a total of 272 students. River Middle uses 5 buses and 3 vans with a total of 241. We want to set up a system and solve it to see how many students ride in each bus and each van. So we don't have a constant rate of change, so we're going to use standard form. So we have 4 buses, so there's so many students on a bus times 4, plus 6 vans. So 6 vans times V is going to represent how many students ride in the van, and there's a total of 272 Creek Middle students. Now let's set up for the River Middle. We have 5 times B, B represents the number of students on a bus, times 3V equals 241. So since they're both written in standard form, I typically like to use the elimination method. So I need a pair of opposites. I don't have one. I could make this 3V become a negative 6V if I multiply through by negative 2. So I'm going to have negative 10B minus 6V equals negative 482. Now I'm just going to rewrite my first equation underneath so everything lines up. And when I combine these, I get negative 6B equals, then I get negative 210, and then I divide each side by negative 6, and B, the amount of students on a bus is going to be 35. So every bus carries 35 students. Now let's see how many students are in a van. So I'm just going to use this equation. You can use either one. And I'm going to plug in 35 for B. I'm finding V, how many students are in a van. And then when we multiply this, we get 175. Subtract out your 175. Divide by 3. And each van carries 22 students. So we had an equation for Creek Middle School students and an equation for River Middle students. The NFMS Band sold 18 adult tickets, 28 student tickets on the first day of ticket sales. The total collected was $312. On the second day, the band sold 28 adult tickets and 14 student tickets where they collected $308. We are asked to write a system and solve it to see how much it costs per ticket. So we have two different types of tickets, adult tickets and student tickets. And then we have day one and day two. So on day one, there were 18 adult tickets. So 18 times how many of our adult tickets cost, plus 28 times how many ever a student ticket cost, and they collected 312 on day one. Day two, they sold 28 adult and 14 student to collect $308. So we are setting up in standard form, and we're going to use elimination. So I have no pair of opposites. I can see that 28 is twice 14, so I could easily make this 14s a negative 28s by multiplying through by negative 2. So we are going to get negative 56a minus 28s is equal to negative 616. Now I'm going to rewrite equation 1 underneath so everything lines up. And we're going to add. So we're going to get negative 38a. The s's are eliminated. Equals 304. And that is a negative 304. Divided by negative 38. An adult ticket cost $8. Now let's just plug that in to our first equation to see what a student ticket costs. So A is 8. And then we'll multiply 18 times 8, and that's going to give us, double check that, 144. Subtract out 144. And when we subtract 312 minus 144, we get 168, and then divide by the 28. And a student ticket costs $6. The NFMS Drama Team sells 124 tickets. The team collects a total of $380. The adult tickets are $8 and the student tickets are $6. So this is different from the last one, but this is similar to one where we have the coins, like quarters and nickels. So we are going to have how many tickets we sold and what type of tickets they are, and then we're going to have an equation to represent how much the tickets are. So we have adult tickets plus the student tickets was 124 in all. The adult tickets are 8. So we're going to say the value of an adult ticket is $8. The value of a student ticket is 6. And we collected 830. So what we're trying to find out is how many adult tickets and how many student tickets were sold. So we are going to use elimination. We can either make this a negative 8a or this a negative 6s. Again, I just always go with a smaller value, so I'm going to multiply through by negative 6. And 124 times -6 is -744. We're going to add these together. This gives us 2a equals 86. The s's are eliminated. Divide by 2. And the adult tickets, they sold 43 adult tickets. So 43 plus S equals 124. So we're simply going to just subtract the 43 from 124, and there were 81 student tickets sold. And I hope this helps.